Hi everyone, this is Math for Teachers Team Teach. I'm Tracy Delgado.
I am Sharissa Armstrong.
I'm Kenny Bird.
And I'm Danielle Gillum.
And we are the Number Ninjas. And we were going to start this out with a joke. And we said, why is the math book always depressed? Because it is full of problems. How funny. Okay, let's get down to business on this first problem. All right.
So how can these numbers equal 27 horizontally and vertically?
That's a very good question, Danielle. I will try to explain this the best I can. We're going to work with the numbers 3, 7, 9, 11, and 15. In this one, I tried 15 plus 7 plus 3, and that equals 25 on vertically. And then 15 plus 9 plus 11 equals 35, so that does not equal our number of 27. The next one, oh shoot, I cannot see mine. I tried 11. I put 11 in the center. I did 11 plus 15 plus 9, and that equals 35 vertically. And horizontally, I did 11 plus 3 plus 7 equals 21. So that also does not fulfill our requirement of 27. This next one, I put 7 in the center. I did 7 plus 11 plus 3 equals 21. And then I did 7 plus 9 plus 15 equals 31, which also does not fulfill our requirement of 27. And then the last one, I did 9 in the center, and I added it to 11. 11 plus 9 equals 20, plus 7 equals 27 vertically. And horizontally is 9 plus 15 equals 24, plus 3 equals 27. And that fulfills that part of our equation for 27.
Thank you, Tracy.
And let's get to the next problem. Can I see? Okay, we were given a circle, a blank circle. There was a 14 in the middle, another blank circle, 16, a blank circle, 1, and then our 13, and then our last blank circle. So I did 9 plus 5 equals 14. And to solve this part, you can either do 9 plus blank equals 16, or 16 minus 9 equals 7. And then this last part, we can do 13 minus 7, or 7 plus blank equals 13, and that equals 6. And this will solve our other problem with 6 minus 5 equaling 1. The next one, we were given 15 in the middle, a blank on the left, a blank on the right, 12, 9, and a blank circle here, 6 in the middle, and 4 on the right. So what I did here was a 10 plus 5 equals 15. 12 minus 10 equals 2. And then 6 minus 2 equals 4. And then 4 plus 5 equals 9. That, by the way, was the puzzle in our original homework that I determined to be unsolvable. So I tweaked a couple of the numbers to make it where it would solve. And this next one, we're given a circle, 5, 3, 10, 22, 11, and then our 2 blank circles. So now we can do 5 minus 3, or we can do 3 plus blank equals 5. So that would be 2. And we could do 10 minus 2, or we could do 2 plus blank equals 10, and that gives us 8. And on this one, we can do 11 minus 8, or we could explain as 8 plus blank equals 11. Oh, I'm sorry, I added on that one. 11 plus 8 equals 19. And on this one, on this side, it would be 22 minus 3 equals 19. And on this last one, we were going to, the last blank circle, a 7 in the middle, blank on the right, 21, 6, blank. I'll put 17, I'm sorry, 8, and then another blank circle. So on this one, I did 4 in the left side. 7 minus 4 equals 3. And that would fulfill this part. Is 21 minus 4 equals 17. 17 minus 8 equals 9. 6 plus 3 equals 9. And that is mine.
Okay, problem number 2. Okay, 5 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. See the 2 examples. The squares all have sides of length 1. There we go. Those are my examples. Sketch all possible figures which can be formed and calculate the perimeters of each figure that can be formed. And the perimeter is the distance around each figure. So, okay, I arranged those tiles in a little figure there. Go ahead and click again. That's the perimeter of 12. The way I counted it is I start just on each side, and you count from the top box, and you go 1, 2, 3, 4, 5 on the sides, and then 6, 7, 8, 9, 10, 11, 12. So you just count along each side, and the perimeter of that one is also 12. Just go ahead and keep clicking all through here, and there'll be more figures. Or sorry, that one's 10. Go ahead, keep going. There's more. All right, and the perimeter of that one is 12. I have more figures that I laid there we go. I think those are perimeters of 12 as well. You just have to count each one their length of 1. And which figure has the least perimeter and which has the greatest? So the one that has the least, which would be the 10s, or the ones that are closer to kind of a square formation, which the most tiles are touching each other. And then the greatest perimeter is 12, where the tiles are in a line. Oh. Okay, so Kenny, how did you find or come up with the rest of the sequence and get to 25 in this pattern?
Okay, well, what I did, it asked me to figure out the fourth one. And so what I did was I tried to figure out what's the difference. So I went from my first one, which was 1, and then it was 4, 9, and 16. So I'm trying to figure out what's the difference. So then when I seen the 1, the 4, I said, okay, there's 3. And then I go to 4 and 9, that's 5. And then I go 9 to 16, and that's 7. And I'm like, they don't have the same difference. Then it kind of hit me that, hey, it looked like they're adding to the difference. So it's 3, then there's 5, then there's 7. So let me try 9. And then it was 25. So I said, that must be it. And then that seemed like that works in the sequence. And then, so then I went and added, and you can see how I did it, where it's 1 equals 1, and the 1 plus 3 equals 4. And then instead of adding 3 again, I added 5, which gave me 9. And then I did 9 plus 7, which is 16. So the 5, I added 7 instead of 5. And then it kept doing that from 16 plus 9 to 25. And then I went, because it asked me to do a few more. So then I did 25 plus 11, which was 36. And then 36 plus 13 was 49. Then it also hit me. I'm like, all those look like they're square roots. So then I can do this. I can do 1, whatever the sequence is, which would be A1, which will be the sequence. So if it's 1, I can plug in 1 for n, and then times that by 2, or not times, but I would a subscript of 2, which would give me the square root of it. So that's how I got the 1, 4, 9, 16 to 25.
Okay.
Okay, ready to ask question. To number problem 4. Sharice, how do you know this was an addition pyramid, or what is an addition pyramid?
An addition pyramid is when you take it totals the boxes underneath what you're working on equal the top of the pyramid. So the ones under it add up to each other to equal the top. And you can solve the empty boxes in a pyramid using formulas. So let's solve some. For each incomplete addition pyramids, you need to show the values in each square by forming and solving an equation in the unknown variable. And you need to write an equation to solve each pyramid and show your work. So let's go ahead. Okay. What do we know? We can see that 26 is at the top. We know that the left empty box is x plus 9, and the right empty box is 9 plus 5. So go ahead and click through. And one more. Okay, so I added 9 plus 5 equals 14, and 26 I know is a total of 14 and some number. So if I subtract 14 from 26, I can find the left box. So 26 minus 14 equals 12. So the left box is 12. 12 equals the total of the 2 under it, x plus 9. So 12 equals x plus 9. Subtract 9, x equals 3. And we have solved all the unknowns in that pyramid. Let's do another one. In this one, we know that 3 plus y equals the left box, y plus 5 equals the right box, and both of those together equal the top of the pyramid. So we're going to substitute in those equations. Let's see here. So 3 plus y plus 5, that'll equal 24. We have 2 y's there, and 3 plus 5 equals 8. So 2y plus 8 equals 24. Let's simplify it a little more and subtract 8. 2y equals 16, and then y will equal 8. So there we have solved all of the unknowns in this pyramid. Let's do one more. Okay, so with this one here, we actually are going to label the unknown in the middle at the bottom A, and the unknown on the right B, and Z actually came and understood. So we know that Z equals 3 plus A, and the right box is A plus 11, and the top is Z plus A plus 11. We can factor that out, 3 plus A and A plus 11. That's 2 A's there, and 3 plus 11 equals 14. So 18 minus 14 equals 4. 2A equals 4. Divide it by 2. A equals 2, and then we can also figure out B with that. Go ahead and click through. Those all should.
Oh, shoot.
Oh, okay. It's okay. Okay, so, Danielle, I guess, if you know just some information about couples but not everything, are you able to figure out who's actually married to who with some clues?
Yes, if you have some clues, you can use the process of elimination in order to find out who's married to who. So we're going to do some problems and take a look at that, of the process of elimination. So 4 married couples are seen together at a high school reunion, but you were unsure of who was married to who. So to save yourself using the you click the next slide. There we go. All right, let's start with the basics. So the wives are Jackie, Stephanie, Paige, and Helen. And then the husbands are Alex, Calvin, Brandon, and Mark. And we're going to try to figure out who's married to who. So we can't remember who's all married, but here's the clues. Mark is Paige's brother. Brandon and Paige had a history, but it didn't work out. Jackie is now married to Calvin. And Stephanie met her husband through Paige's brother. So we already know Jackie is married to Calvin. And so we're going to put a heart by that, by both their names, and put an X throughout the rest of Calvin's relationships and Jackie's relationships. And then we know Mark and Paige aren't married because they're brother and sister. And then Brandon and Paige obviously didn't work out. So we know Stephanie met her husband through Paige's brother, which is Brandon. So they can't be possibly married. And that's how you're going to do that. So click to the next one.
Danielle, how can you can a trapezoid numbers ever be negative?
It cannot, and that's why we're going to look at even numbers. The number sequence below is going to be considered a trapezoidal number. So you start with the equation of 1 plus 1, 1 plus 2 plus 2 plus 1, and keep going down to where whatever nth number you're solving for, you'll keep going through that. But there's easier ways to do that with a formula. So you're going to consider possible ways to find the equation. And let's start by making a table with the term numbers and their sums. So if you're starting with the nth number of 1, you're going to multiply it by that second number. So your 1 plus 1 is solved to be 2 in the green on the right. And then after you're trying to find the second one, so 2 is added twice. So it's going to be 1 plus 2 plus 2 plus 1. And the sum of the numbers is 6. And then 1 plus 2 plus 3 plus 3 plus 2 plus 1. Your sum of your numbers is 12, and then you'll go on, so on. And if you'll click to the next problem, you'll examine the table and note that any patterns that may give us clues on how to find an equation fits. The rate the term increases tell us that there is a multiplication of n at some point in the equation, and that's going to be the formula. So we're going to take several totals, divide them by n, since we believe there to be a multiplication of n, and we're going to dig deeper to find the insight into what's happening in this trapezoidal number. So if you're trying to find the nth number of 2, you're going to do 2 divided by 1 equals 2. And then the nth number, 6, is going to be 6 divided by 2 equals 3. T3 equals 12. So 12 divided by 3 is 4. And then the fifth one is going to be 5 times 4 equals 20. And that's how you find that 20. And click on the next thing. So now we can see a clear pattern. We can now make a formula to determine the sum of any term. So,
Well, I guess that was the end of our video. Thank you for solving problems with us. It was fun.
Yes.
All right, you guys. Thank you so much. Bye.
Bye.
Bye-bye.